Okay, so we are going to study today about the basic elements of a push down stack memory machine. Okay, a push down stack memory machine is a computational model that is used to solve any problem that has an algorithmic solution and requires a single stack of infinite memory as storage. Okay, push down automata can arbitrarily remember long input strings, unlike your finite state machines. Okay, because these finite state machines do not have any memory associated with it, but in the case of push down automata, it is associated with a stack which acts as an infinite memory storage. Okay, so PDA or push down a stack memory machine can accept or recognize context free languages as well as regular languages. So we can say that push down stack memory machine is a finite state machine with an external memory. Okay, now what does this push down stack memory machine contains? It consists of an input alphabet sigma, which is a finite set of input symbols. It also consists of an unbounded input tape, and the tape has to be bounded on one side. Okay, the left hand side of the tape will be bounded. Okay, or the left hand side of the tape is fixed, and the length of that input tape will be unbounded. That is, it is only bounded by the input length. Okay, so if you look at the diagram, you will see that the tape is divided into cells, and in each cell we can place our input symbols, and those that are containing no symbols in them are represented by this blank character, that is B followed by this slant line. Okay, then there is an alphabet of stack symbols called as 2, okay, which basically represents symbols that are present on the stack, which is our external memory. Okay, so the stack is a push down stack. So initially the stack is empty and is assumed to contain a blank character at the bottom. Okay, so there are other states, like you have a start state, the accept state, and there is a reject state. Okay, all of them which indicate whether the process has started, whether we are accepting the whether the string is accepted or whether it is rejected. And then we have a branching state called as read. Okay, and we have stack operations like push and pop. Okay, just right. So if you look at the elements of the push down machine, so these are the elements that are present. Okay, these elements are taken from the author Vivek Kulkarni's book Theory of Computation by Vivek Kulkarni. So here we have the start process, which is in form of an ellipse. Then we have a read, which is represented in the form of a diamond, and it shows that when an input, depending on which symbol has been read, we can move to that particular direction. So if I read an A, we move upward. If you read a B, we move towards the right, and if you read a C, then we move towards the down. Then we have an accept condition, where we accept that the string belongs to the language and we halt. And we can have a reject condition, where we have concluded that the string does not belong to the language, and if we reach this particular state, then this string is rejected and we halt. Since we have a push down automata, since push down automata is associated with stack, to push an element onto the stack, we use this push, which is represented by a rectangle, and we can push followed by the alphabet that we wish to push onto the stack. So either once we push, we either move towards the left side or to the right side. The flow of direction can be left or right. And then we also have another operation, which is pop, that is when I want to pop an element from the stack and I wish to compare it with the symbol that is being read, then we can use this pop operation, which is very similar to read, okay, represented by this diamond shape, where we have, if we have read a symbol X, then we move read in the sense we have popped a symbol from the stack and that symbol happens to be X, then can we move upward? If it is Y, we move rightward, and if it is Z, we move downward. That would indicate the flow of a direction, right? And just to represent this push down automaton or a push down automata mathematically, we represent it using this M, which is a tuple consisting of a finite set of states, an alphabet set which are input strings, right? The input string is composed of certain symbols. Those symbols are called as an input alphabet. Like I mentioned, these symbols would be on the tape, which is fixed on one side, the left side, and towards the right it is unbounded, bounded only by the length of the string. So if my input string has 4 symbols, then the tape would have 4 cells, okay, and you could have extra 2 cells to represent the blank characters. Okay, then we have a stack alphabet represented by 2, which indicates that these are the symbols that can be present on the stack. What you need to know is the input alphabet and the stack alphabet need not be one and the same. They can be one and the same, or they need not be one and the same. They can be different symbols, okay, or it could be stack alphabet could include the symbols of input alphabet and a few more, okay. Then Q0 indicating the initial state, which would be a member of the finite set of states. Z0, which indicates which is a member of toe, okay, that is a particular stack symbol called as a start symbol, so it indicates the bottom of the stack, the blank character. So how do I show that my stack is empty? So we could use this symbol called as Z0. So if my stack contains only Z0, then I would say that the stack is empty. And F represents the set of final state, which is a set of represented by a capital F, which is a subset of Q, okay. And then we have this delta. Delta would be transition. So how do I make a transition? For that I have to consider the state I am in, the symbol that is being read from the tape, and what is the current symbol on the stack. So we consider these things and we make, how do we make and where do we make transition? I move to a different state and there is some operation that happens onto the stack also, either a push operation or for the pop operation. And this delta we are seeing represents a deterministic push down automata. For a non-deterministic push-down automata, the difference only occurs in the concept that I am going to include epsilon as a part of my input symbol. So looking at the current state I am in, looking at the symbol that is present on the tape, looking at the epsilon, or which would also include epsilon, and I will also consider the state of the symbol, state of the stack, that is the symbol that is present on top of the stack, and there would be a transition to one of the finite states of Q, and there would be some operation on the stack. So this is about the basic introduction as to push down automata.